Hey guys, Zachariah J here, IVC student in Precalculus. I'm going to start working on our Chapter 1 and Chapter 2 exam review questions that our instructor has given us. I've kind of decided I'm probably only going to do videos for the reviews that our instructor gives us because there's just way too much homework in the class for me to do all the problems for the videos. The videos just turn out to be so long. So even this video is going to turn out to be pretty long, even though there's only 36 questions. But I feel like you're just getting one or two questions from each section in the exam review, and you'll get the concept, so you'll be able to do the homework, or you should have already done the homework, really. So I'm just going to do the exam reviews and see how that goes. Make sure I can keep up with all my other classes as well. So let's dive in and get started. All right, for these first problems, we're supposed to find the distance between point 1 and point 2. So find the distance, starting off swimmingly here, the distance. And to do that, we need our distance formula. D equals the square root of x2 minus x1, that's squared, that quantity squared, plus the quantity y2 plus, minus y1 squared. Wow, I hope I don't keep making these mistakes all the way through this video. It's already going to be really long. All right, so let's define our x2 and x1. I'll pick this point to be x2, y2 because it's point 2 anyway. And I'll make this one x1 and y sub 1. Should be saying sub. So I'm just going to plug these numbers into our distance formula. So let's take the negative 3 and minus 0. We'll square that. And then add the 10 minus 10 and square that. And this is all under the radical. Try to make that so it's not crossing things out. There we go. All right, so this is our distance. And let's just start simplifying this equation. So negative 3 minus 0, well, that's just going to be negative 3, and that's going to be squared, plus, well, 10 minus 10 is 0 squared. It's really nothing. But we'll just keep it there. Now, negative 3 times negative 3, well, that's 9, and that is under the radical. And then the square root of 9 is 3, and so our distance is going to be equal to 3 for this first problem. So that one's pretty easy. We'll move on to number 2 here. And let's just label our x sub 1 and our x sub 2. So our distance formula is going to be x sub 2, x y sub 2, x sub 1, y sub 1, and then so distance is going to be, get this out of the way a little bit. Got them a little close. All right. Distance is going to be the 9 minus 0, that quantity squared, plus the 3 minus 0 squared, all under the radical. And, well, 9 minus 0 is going to be 9, and the 3 minus 0 is going to be 9. So just put those squared under the radical. So 9 times 9 is 81, plus another 9 under the radical. That's going to give us 90. And, well, 90 is 9 times 10. So we can just write that as 9 times 10. And then that means we can change that 9 to a 3. And so it's 3 times the square root of 10. So that is going to be our distance for number 2. And there you go. So we'll move on to number 3 here. And in number 3, we are decide whether or not the points in the are vertices of a right triangle. So a little bit different here. So that's for these next few problems. And I've already labeled or created the triangle for us to make this video go a little faster. And I labeled the points A, B, and C. So really what we need to do is we need to find the distance. There's a couple ways that you can go about this, but in class we were using the distance formula. And so the distance of, oops, here we go. The distance between A and B, we can put that all into the distance formula. So that's going to be this point, which is going to be -1 plus 9. Now remember, since we subtracted negative, we changed that to a plus, and that quantity squared plus, and what is that, 6 minus 6, and that quantity squared. We start reducing all this down. 6 minus 6 is going to be 0, so this is going to be 8 squared under the radical. And so really that radical and the squared is just going to cancel itself, and so our distance is going to be 8. So here we go. Our first distance is 8. I can already see that the right angle is supposed to occur at B. So let's just do the distance from B to C. And, whoa, let me fix that. And we'll just put in our points into our equation. It's going to be -1 plus 1. Yes, plus 1 squared. Remember that subtracting a negative converts that to a plus. And then we got 9 minus 6 squared. And this is going to cancel out, so we're going to get nothing here. And 9 minus 6 is 3. And that's squared. And this, whoa, let's make that a 2. Okay, and so the square root of 3 squared is, it's just going to cancel out, so it's going to be 3. So this leg is 3. Now, if we really want to continue using the distance formula, well, we're going to have to find the distance between A and C. And that is this leg right here. And to do that, we need to sub in all of our values from those 2 points into our distance formula. So we'll start off with -1 plus 9 squared plus, and we'll go with, what do we got, 9 minus 6 squared. There we go. All right, so now we got 8 squared plus, let's 3 squared. There we go. And this is going to turn into 64 plus 9. And under the radical, of course. And then, so that's our distance is going to be the square root of 73. All right, well, how do I prove mathematically that this is a right triangle? Well, we know the Pythagorean theorem works with right triangles. So we've got a squared plus b squared equals c squared. So we can just do a check. And of course, we can move that squared over. So we can do the square root of a squared plus b squared, which is where our distance formula even really comes from, right? So we can just plug in our 2 legs that we feel are going to be our legs for a right triangle and see if that equals what our hypotenuse is that we found from our other formula here. So we got 8 squared plus 3 squared under the radical should equals c. Well, we can see right off the bat that this actually equals that. So, yeah, computer's doing weird stuff. So really, it's going to come down to equaling the same thing if we did all this math correctly. So that kind of proves the fact that it is indeed a right triangle. So, and this is where that right triangle, it occurs, so to speak. Now, that's the way we do it in class, or we did do it in class, but as an alternate way, let me see if I can do this over here. Other things that we learned in class and we didn't really associate with this is the fact that we have ways of finding out if things are perpendicular to each other. So I prefer this method because it's a little bit faster for me. So I know that the slope of a line AB, between A and B, it's going to be y sub 2 minus y sub 1 over x sub 2 minus, x sub 2 minus x sub 1. So if I plug those in for my A and my B, I get 6 minus 6 over negative 1 plus 9, which is ultimately going to be 0 because 6 minus 6 is 0 and divided by anything is 0. So 0. And my slope for my other leg that I have theorized as being where the right angle is BC. So plug in all those numbers to my slope formula, and I get 6 minus 9 over negative 1 plus 1. And that's undefined because I'm going to get 0 in the denominator, right? Well, if I think about this in the space way, I know that this actually equals a vertical line in this case. Let me get this circle here better. There we go. So this guy right here is a vertical line. Just write down vertical. Because we know if the slope is undefined, it's vertical. And then this line right here, since the slope is 0, we know that's a horizontal line. Now, if we have two lines, one being horizontal and one being vertical, well, we know that those two lines are perpendicular. Whoa, let me hit P. There we go. Perpendicular. So here we're proving using this method that we have two perpendicular lines created by the lines used in the triangle. So we've got a right triangle. So I'm going to use that method for this one as opposed to the distance formula because this triangle is a little bit crazier. It's not easy to see where there could be a right triangle. So I'm just going to do a slope formula for each of these lines to find out what the slope is for each line. So the slope for AB is going to be negative 5 plus 7 over negative 4 plus 10. Remember, all those negatives change it to pluses in the middle here instead of minuses. So I'll show that this is point A, this is B, this one's C. So since I'm doing A and B, that's where I got my numbers from, right? Okay, so on the top I'm going to get 2, and on the bottom I'm going to get 6. So really this is 1/3. So then I'm going to do my slope for my B to C. So this guy here is going to be negative 10 plus negative 5. I'm sorry, minus negative 5, so it turns into a plus. And on the bottom, we got negative 5 plus 4, and that's these 2 points right here. So I should have changed the whole color, but I'll just star this one so you kind of know that that's where I'm getting this from. And let's see, we're going to get 5 on the top here, minus 5, and we're going to get, should be a minus 1 there. Let's fix this, minus 1. There we go. And so we're going to end up with, oops, leave that minus there. All right, so and a minus on over a minus, that makes it a positive, so we got positive 5 here, right? All right, so let's do the last line and find out that one's slope. I don't know, I just feel like finding the slope is easier than doing the distance formula. So we're going to do A and C here. Let's plug these in. It's going to be a negative 10 plus 7, and then we're going to have negative 5 plus 10. There we go. All right, so now we're going to have negative 3 over 5. So we got negative, hang on, yeah, we've got negative 3/5. Now, if I look at all these, to be a perpendicular line, the slope needs to be the inverse reciprocal. So to be perpendicular, the slope needs to be inverse reciprocal. Slope needs to be inverse and reciprocal. And so what does that mean? That there we go. So what that means is we need to have one pair of these lines have exactly the opposite, being the opposite sign, plus or negative, and the reciprocal over the top. So we got the reciprocal of 1 over 3 is negative 3, and nothing else has that same slope. Nothing has negative 3. The reciprocal of this is going to be negative 1 over 5, and nothing has that. And the reciprocal of this is going to be 5 over 3, and nothing has that. So nothing here is perpendicular. So therefore, there is no right triangle. So this triangle is not a right triangle. So that's the easier way I feel like doing this. So therefore, no right, oops, no right angle. You wrote perpendicular, so no right angles. So we don't have a right triangle. So that's just my easier method, I think. Okay, moving on to number 5. Oh boy, we got something crazy here. Find all values for k so that the given points are square root of 9 units apart. Well, we've already been given a point of negative 5, 5, and it's square root of 9. And we're given this point of k 0. So the y is 0. It's the x-axis. It's 0. So I need to find the point on the x-axis that makes this triangle. Oops, hit my volume key there. Sorry about that. So this leg here is, whoa, doing all kinds of crazy stuff. Square root of 29. And this leg of the triangle over here is also square root of 29. So I need to find the points on the x-axis, because y is 0, that I need to find my x values for this. So k comma 0, and this is going to be another k 0. So, what is k? Well, since we know the distance, we're going to use a distance formula here again, since we've been dealing with the distance formula for quite a while. So since our distance is 29, square root of 29, we'll just start with that. We'll write that down. Square root of 29 is equal to, and then we'll just substitute all the rest of what we do know into our distance formula. So we'll have to label one of these points as, well, I mean, we're using the negative 5, 5, and the k comma 0. So I'll just put the quantity x plus 5, that squared, plus, well, I know the y coordinate is 0, but I don't know. Oh, yeah. So we got 0 minus 5 and that squared. It's hard for me to talk and write at the same time sometimes. So I don't know what that other x coordinate is. So that's why I've got x plus 5. And this is where I got this 5. It was the negative 5. So x, this x here, minus a negative 5, which turned into a plus 5. So that quantity squared. And then for my y's, I pulled, well, this is my y here that I'm looking for, or that I'm looking for the coordinate pair for, and here's the other 5, so minus 5. So just trying to clear all that up. So we got square root of 29 equals the square root of, not pen. All right, we still have this. We're going to solve for that x, and then 0 minus 5, well, that's going to be negative 5 squared. And negative 5 squared is going to be 25, of course. So let's bring this all down. This, and I'll move the radical over. So this is square root of 29 squared. So x plus 5, that quantity squared, yeah, plus 25. And then when we look at this square root of 29 that's squared, well, that's going to end up being 29 minus this 25. We'll move that 25 over. And then we're going to still have the quantity x plus 5. That's squared. Well, if we take 29 minus 25, we're going to get 4. And we've got a perfect square over here, so it's going to be x. We'll factor that out to be, let's see, write that down so I can kind of visualize it here. So I'm really just going to put 4, and that's going to be x squared and plus 10x plus 25. There we go. All right. Well, now what? Let's move this 4 over, and we're going to get 21. So 0 equals x squared plus 10x plus 21. All right. Well, now we can factor that. So what makes 21 and 10? That's going to be a 3 and a 7. So x squared plus 3 on this side. Yeah, 3x plus 7x and plus 21. So now we can factor out an x from this first section, x to x plus 3. And then that's going to be plus 7 times the quantity x plus 3, of course. We've done our factoring correctly. So now we're going to have 0 equals x plus 7 times the quantity x plus 3. And so that means we have x is equal to negative 7. That would make the above 0. And then x is equal to negative 3. That also would make this equation equal 0. So our two x coordinates are negative 7 and negative 3. Those are the only two. So negative 7 comma 0 here. And negative 3 comma 0 here. Those are the only two coordinates on the x-axis that are going to actually have a distance of square root of 29 and intersect that axis. So there you have it. That's kind of a tricky question, the way it's asked. You have to pull a lot of knowledge about triangles and squares and whatnot out of there. So anyway, it's time for us to move on. Oh, here, I'll write down all this and just put it in a box so it's nice and neat. There we go. Let's move on to number 6. And 6 says, let's get this straightened out. If negative 2, negative 3 is the endpoint of a line segment and 2, negative 4 is the midpoint, find the other endpoint. Okay, well, this is a midpoint formula problem. So this is one endpoint, and this is the midpoint. And this what is the other endpoint is really what we're asking here. So let's see here. We've got our midpoint formula over here. Let's just start substituting stuff in here to find, substituting into this formula right here, so we can find what our other endpoint would be. So we've got 2, -4 as our midpoint, and that is equal to, and I'm going to just sub in 0.1 information into this. We've got -2 for an x, plus the second x, which we don't know, divided by 2. And then we're going to have -3 plus y over 2, because we don't know the second y coordinate. So we can set this -2 plus x divided by 2 equal to 2, because we know that that's what it's supposed to equal from our midpoint. And from here, we're going to just start simplifying. We multiply both sides by 2 in this case. So we're going to get -2 plus x equals 4. And then, of course, get x on it, we're going to add 2. So we get x equals 6. So our x coordinate, or x component of our ordered pair, is going to be 6. So this was how to find our x, this column. Our y, we've got -3 plus y all over 2, and that's going to equal -4. And that came from over here. And so from there, we're just simplify. We'll multiply both sides by 2. That's going to be -8. And then we're going to add 3 to both sides. So yeah, we'll get y equals -5. So there's our y coordinate, or our y part of our ordered pair. So we've got our second endpoint, or point 2, is going to be 6, -5. And put that in a nice little box. There you go. So pretty simple. Number 7 is exactly the same problem. I don't know why for the study guide we have 2 of the same problems, but we'll just do this one too. Exactly the same way as we did before, but I'll just kind of skip right into it. Our x is going to be equal to our, this half of the midpoint formula is, let's see, -1 equals 4 plus the coordinate we don't know divided by 2, multiply both sides by 2. Here's where I got the 4 from. Multiply both sides by 2. That means we're going to get -2 here. 4 plus x, subtract 4 from both sides. We're going to, and that equals x. So that's going to be -6 equals x. That's the first part. And now I will do my, not x part, my y part. That's going to be the -5 and the -7. So these two components I'm going to sub into my formulas. Oh, looks like Dwayne wants to do some flying tomorrow. Sorry about that. Finally responding to my texts about going flying. All right, so where were we? -5, -7 plus y over 2. Multiply by 2 on both sides. That's going to give us -10. And this is -7 plus y. So we add 7 to both sides. That's going to be -3 equals y. So our new ordered pair here is going to be -6, -3. That's our other end point. All right. We'll move on to number 8 here. The medians of a triangle intersect at a point. The distance from the vertex to the point is exactly 2/3 the distance from the vertex to the midpoint of the opposite side. Find the exact distance of that point from the vertex A3, 4 of the triangle, given that the other two vertices are at 0, 0, and 8, 0. So here's all these points that they've kind of given to us in our word problem here, and labeled them all for you. And I pre-drew the triangle. I've learned my lesson. That's taken way too much time. So we're going to try and find the midpoint between BC here that I've marked here in orange. So we've got BC, midpoint. We're just going to put all this information. We got 0 plus 8 over 2, comma, and then we're going to get our 0 plus 0 over, oh, not over 6, over 2. There we go for our other coordinate. So this is going to 8 divided by 2 is going to be 4, and of course it's 4 up here. 0 divided by 2, that of course is going to be 0. So that's going to be our other part of the coordinate pair. So 4, 0. Now we could have seen that on the number line here. We know that that would be the midpoint. That's why I selected this line to do this with. You could have done it with any one of the lines, but this one just seemed to be the easiest to me. So here's this line. But remember, in the problem, it said that we were going to be 2/3 the distance here. So we're going to be, we can either start at A or from this point over here, but we're only going to make it 2/3 across here, that 2/3 distance. So we're going to do a distance formula between A and, I guess I should really name this other point. I'm going to put the 2/3 down here first before I forget it. 2/3 this distance. And A, but let's name, like I said, name this other point here. We can name it anything we want. We already got ABC, so why don't we just put D here? D. And then we're just going to substitute all our information into the distance formula from the points A and this D, which was our midpoint. Oh, come on. Okay, so doesn't really matter which one we call which one, but so I'm going to just put, let's do 4 minus 3 in the square of that quantity plus 0 minus 4, and that quantity squared, of course. And we'll work our way down this whole thing. This is going to be 1 squared. Yeah, these are the 2 points that I used. So this is going to be 4 minus 3 is 1, so that's going to be 1 squared. Let's get all my colors coordinated here. And this is where I got these 2 numbers from, just so you can follow along here, I guess. All right. Like I said, 1 squared plus 0 minus 4 is going to be negative 4 squared. And that under the radical, which is going to be 1 plus 16. And that under a radical, so that's 17. Okay, but we said it's 2/3 this distance. Remember this 2/3 over here. So we're just going to take 2/3 times the 17 under the radical, so the square root of 17. So put 17 over 1 here. That gives us 2 times the square root of 17 over 3. That is our distance, folks. Right there. So not too difficult, although it's kind of hard to get what you want out of the words on the page. This one, number 9, we're supposed to list the intercepts of the graph. Well, it's pretty easy to see where this is intercepting the graph. It's right here, these 4 places. Um, we're not really given any coordinates or anything, so we're just supposed to go off the graph. This is 7 up. This is 7 to the left, so that's going to be a -7. This is 7 down, so that's also going to be a -7. And this is 7 over here as well, so it's a perfect circle. So we just got to put a bunch of zeros with these 7s. So we got a 0, 7. We've got a coordinate pair of, I'll make sure I write these all down right. I guess it's pretty easy, but 7, 0, and now we're going to do -7. So we have to do those 2 pairs again with a -7. So we'll just do 0, -7, and then we'll do a -7 and a 0. So there we go. It's reflecting around the whole thing, so pretty nice. So move on to number 10 here. And in 10, 11, and 12, we are supposed to find out if this is going to be symmetric to the x. Is the equation symmetric to the x, y, and origin? X-axis, y-axis, and the origin. And we do that for all 3 of these. And, well, for 10, 11, and 12. So for this problem, number 10, to find out if it's symmetric to the x-axis, what we do is we substitute -y sub -y for y. And then we see if we get the same equation after we do this substitution. So we've got yx squared plus 16 times the quantity -y squared plus equals 64. Well, -y squared is going to return a positive value, so it's really the same as positive y. So I can rewrite the equation, and you can see that we get the same exact equation as what we started with. So therefore, this is symmetric in respects to the x-axis. And so symmetry to the y-axis, we do pretty much the same thing, except we sub -x for x. So sub -x for x. And that's going to be 4 times the quantity. Oops, that's not quite wide. Be able to get my parenthesis in there. There we go. Okay, -x squared plus 16y squared equals 64. You can see that this -x squared would turn out to be the same thing. So this is the same formula, even though I forgot to put the squared on the y there. You just know that that was supposed to be there. Now we look at symmetry in respects to the origin. Well, in this case, we sub -y for y and -x for x. So we do both substitutions. But we've already done it for each of them individually and discovered that it's going to be symmetric. It's going to be the same value. So why would it be any different here? It wouldn't. So this problem or this equation is symmetric to the x-axis, the y-axis, and the origin all at the same time. And the reason that is, you know, let's get this to be a square. There we go. Rectangle. Parallelogram. Now, the reason this is symmetric is because of these squares here. So looking at these next couple problems, 11 and 12, these are equations that have only one component squared. So this one has the x component squared. So this is going to be symmetric to the y-axis because we can put in any value plus or minus for x. So it can be either on the left side of the y-axis or the right side of the y-axis. So this is only symmetric to the y-axis. The y is not squared, so it's not symmetric to the origin. Now, 12, the y squared. So that means it's going to be symmetric to the x-axis. We can get a plus or minus value for y, so it can reflect across the x-axis. So there you go. Now, if the line passed through 0, 0, then you might have an origin, but we know that this one doesn't. So there you go. So let's look at 13. Find an equation for the line in the indicated form with the given properties. And both 13 and 14, same instructions, and they want it in general form for both of them, actually. So we'll do it in general form. Well, we'll get it in general form, rather. This is our general form for a line. It's ax plus by equals c. So first thing we need to do is we need to figure out the slope of the line. Slope, which is, again, as a reminder, m y sub 2 plus, oh, wait, this is not a plus up here. It's a minus. All right, there we go. So, well, we have these 2 points. We're going to use the 0 from this one and the minus 3 from this one. Remember that minus is going to turn it into a plus in our equation here. So we got 0 plus 3 all over, use these 2 coordinates. So our 6 plus, or sorry, minus 8. So that is going to give us 3 and a negative 2. So our slope is negative 3/2. There you go. Now, how do we get this into a general form? We can start with our point slope form, which, as a reminder, is y minus y sub 1 equals our slope times the quantity of x minus x sub 1. So it doesn't really matter. We could use either one of these points, but and plug it in for our y's. But I'll just use this point just for fun. I know it's our point 2, but we'll do that one. Y minus 0 is equal to our slope, which is negative 3/2, times the quantity x minus 6. There's 6 from up here, so there you go. Now, we're just going to distribute this negative 3/2, which we're going to come up with a y. And y minus 0 is just y, so just simplify that now. Plus, negative times a negative is a positive, and that's 6. Let's do some quick fractions over here. It's going to equal 9, but I just want to show you how I get that. 3 times 6 is 18, and the 2 times 1 is 2, and so that is all going to equal our 9. These are pluses, not bad. All right, so there you go. That is going to be our y-intercept form, but we need to change it to our general form. And our general form basically has all of this stuff over on the other side. So y over 9. So we're just going to move the x component over here to this side. Equals 9. And there we go. And actually, you're supposed to get rid of that fraction, but I'll let you do that on your own. The video's getting too long. So number 14. It's again same thing. So just do that. Find our slope. 5 minus 9 over 0 minus 5. This is where I'm getting my numbers from. And that is for this portion. So for the top, we're going to get 4 minus 4, and then a minus 5 on the bottom. So this ends up being plus. 2 negatives equal to positive, so we got 4/5. Now we need to use our point slope form. It's a different color here. Not x, y. There we go. Y minus 5. I'm using this point here. Equals 4/5 times the quantity x minus 0, because this is, you got to use the same point, the same pieces from that point. Can't end up using that 5. So distribute this. 4/5 of 0 is nothing, so I just leave it like this. And we got y. We can add both 5 to both sides, so I'll just put this 5 over here, but we're adding it, right? So plus 5. There you go. There is our y-intercept form. Then we move to general form. And so we got negative 4/5 times y equals 5. And we're not supposed to have negatives. So we can multiply all this times negative 1. So that's going to just change all this. And there you go. And again, you're not supposed to have fractions either, but I'll let you guys do that on your own. You can clear that fraction by multiplying by 5. All right, number 15. Let's see here. Find the equation of the line of given properties, and we have perpendicular to the line -5 minus y equals 2, containing the point 0, -2/5. So let's get started on this guy. We have -y equals 5x plus 2. So just reordering this. And we can't have negative over here, so let's just change this all around. X minus 2. Just got rid of that negative over there. So to be perpendicular, we need something opposite and reciprocal of the slope that makes it perpendicular. I kind of hinted at that earlier, finding those triangles, right? So opposite reciprocal of the slope of -5 is 1/5. So we change the sign, and then we also flip the fraction. 5 over 1 turns into 1 over 5, right? So we can just rewrite this point slope form, or sorry, not point slope form, y-intercept form. Y equals 1/5 x minus 2/5, because they gave us our y-intercept in this particular problem, so that made it really easy. So moving on to number 16, it's the same kind of question, where we need to find the slope of this line before we can find what's parallel to a line with 5, 3 in it. So we got 2y equals -3x plus 17. and divide both sides by 2. That's going to give us negative 3 halves x plus 17 divided by 2. Well, we only wanted to get the slope out of this, so it's minus 3 halves. That 17 would be over 2 as well, but anyway, we just wanted the slope from that line, and that's what it is. So we're just going to substitute that slope into our line over here. So we'll have y equals negative 3 halves x plus b. Now we'll substitute this ordered pair of 5, 3 in this formula. We'll have 3 equals negative 3 halves x, which is a 5, plus b. So first things first, we will have 3 halves times 5 plus 3 equals b. So now we need to do the multiplication here, make a fraction, so that's 1. So 3 times 5 is 15 over 2 plus 3 over 1, that would be 6 over 2. And so that's going to be 21 over 2. And so our b value is equal to 21 over 2 equals b, excuse me, not b. So now we can just plug that into our y-intercept formula again. Let's write down y, our slope that we found originally, and that would have been 3 over 2x plus our b value, which was, we just found, was 21 over 2. Now, that would be one answer. Now, of course, we wanted to put it in general form. We would change it, move all the x's and the y's on the same side. So we'd have 3x plus y equals 21 over 2. Now, we can't have a fraction in the beginning here. We have to change it, and so our common denominator here is already there, it's 2. So multiply both sides by 2, so 2 times the quantity 3 halves x plus y is going to equal 2 times 21 over 2. Well, 2 times 3 halves x is going to make me have 3x, and the 2 times the y is 2y, and the 2 times 21 halves is 21. So there you go. There is our answer in general form. Moving on to 17 here. Let's read 17. Find the center HK and the radius R of the circle and given the equation. So already start breaking this out. Make sure you put the space here. I'm just ordering the pairs the way they're supposed to be, collecting kind of like terms. And plus y squared minus 8y plus, leave that space because we're going to have to make some, if it's going to be a circle, it's going to have perfect squares. We'll move this 97 over here, so it's 36 minus 97. Now, let's start putting in, that's going to be 81. This one's going to be, what is this, 16. So remember, if we add 81 to one side, we have to add it to the other. Same thing with the 16. And we can see 81 plus 16, well, those both add together to be 17, so it's a plus 17. These two cancel out, so really we ended up not having to add it, but we have to do it, but this particular example, we end up with that canceling. So quantity x plus 9 squared plus quantity y minus 4 squared equals 36. So now we're going to be able to see that our center is negative 9, comma 4. And our radius is going to be 6. Radius is 6, which is the square root of that 36. So there is our answer for number 17. Number 18, we've got the same kind of situation going, except it's going to be a little more complicated. But 4x squared minus 12x, leave that plus space. Actually, I'll just write out all this so it's all kind of in the right order. And get the 5 on the other side. Okay. So because we have to factor out, I'm going to factor out the 4 here, and then I'll do the minus 12 or minus 3x plus, and then I'll leave that space there. And then we'll do this side, factor out that 4y squared plus 4y plus, leave that little space right there, close that parenthesis, equals 5. Okay, now let's figure out what we got to add to both sides here. Well, let's, how do we complete these squares? Well, this is going to be 9/4. And just as a reminder of how to get that, oh, this one's going to be 4. But that fraction is based off this 3 here, so 3/2. And then we square that to get 3/2 times 3/2. That's where I got that 9/4. So that's where I got that guy. There you go. Now I have to, since I added stuff on this side, I have to add stuff to the other side. So 4 times 9/4. Well, that's going to be 30. That's going to be 9. So let's add 9 over there. And there's 4 times this 4. Well, that's going to be 16. So now we are going to have 30 on that side. So 9, 25, 25, 30, yeah. So that is definitely 30. Okay, cross that out and put 30 there. Now we've got these 4s in front of these little two guys. Well, let's factor these down first. So let's get this to be x minus, well, I knew this is going to be 3/2. Showed the work already. And that quantity squared plus this quantity is y plus 2 squared. Okay. But remember, we have these 4s in front of these guys, really, before these two quantities. Now this is going to be 30. So I was going to try and just do that really quick, but I'll write it so you remember these 4s are in front of here. So we are actually technically divide this side by 4 and divide the other side by 4, right? I was going to do it all in one step, but I'm showing all the other steps. I might as well show that part. So this turns out to be plus y plus 2 squared. So I was going to skip ahead to right at this point, but I thought better of it because the fractions also get in my head too. So this actually works down to 15/2, right? All right, so our center is going to be 3/2, comma, -2. But here's thinking ahead here. Here, our radius problem here is the square root of this 15/2. So really this turns into 15 over the square root of 2. Square root of 15 over the square root of 2. Get rid of this radical on the bottom by multiplying this. And that is going to get us the square root of 30 over 2. There we go. All right, so that's our radius. Our radius is the square root of 30 over 2. This all looks really, really nasty, but that is the answer. So there you have it. Moving on to number 19. All right. This is going to be x squared minus 10x plus, leave our little space here, plus y squared plus 2y plus, leave our little space, equals 10. This is going to be 25. This is going to be just 1. That one's easy. All right. Now we have x, the quantity, sorry, x minus 5 squared plus y plus 1 squared equals, oh, we're going to add our 25 and our 1 to the side. Yes, 36. So 36, that's what I get on that one. So this went really nicely into a circular formula. So our center is going to be 5, negative 1. And our radius is going to be 6. Because I don't know why I put parentheses around it, but that is our radius. I'm getting parenthesis happy. All right, let's go on to number 20. The graph of the function f is given. Use the graph to answer the questions. And number 20 is use a graph for the f given below to find function of 4. So 4, 4, and there is our point that is there. It's 2, so our answer is 4, 2. So really our answer is 2. That would be, if we plugged in 4, we are going to get 2 for our y coordinate, basically. So for this next one, number 21, is F8 positive or negative? Well, count over to 2, 4, 6, 8. Here we go. That's 8. And we see that that point is indeed positive. All right, so we'll just write positive. Put that in our little box. All right, for what number is f of x greater than 0? Well, you look here, wherever anything is above the x-axis, that means our y value is greater than 0. So here we have including, that's why I'm using this squared off bracket, because this is negative 10 over here, and that is a filled in dot. So we are going to include 10, and then we go all the way to negative 6 here. But because it's greater than 0, we are not going to include that. So we use just a parentheses. And then we have another section. So we have a gap here. So that's kind of what this little U thing means. And that starts at 8. But we're not going to include that because that is actually at 0 at the number 8. Wait a minute. Oh, my graph is slightly off on the lines. See, some people laugh at me at, see how this, my y-axis is kind of midway between. Let me try and fix this. People laugh at me at being anal about getting the graph correct. Well, this is kind of why. This is really supposed to be a 7 here. And then it also goes all the way over. Let me move this to make this better. Try and get this right on one of those grid points so it helps us see what we're trying to see here. Okay, well, now you can see that last point on this squiggly line actually falls on 10. But remember, 10 at 10 it's also on the x-axis, so we don't include that one. So here is our answer for number 22. I'll go on to number 23 here. And f of x is equal to this formula. Well, this portion here cannot equal 0. Cannot equal 0. So let's just set a formula for that to be 0. And we find that x, in this case, would be equal to negative 4. Now, if we plugged in negative 4 into the equation, this would make the denominator 0, and thus making the formula undefined. So this makes the denominator 0. And we can't have that, so that brings back a false reply for the argument here. So in set builder notation, I always forget which one's which, but there's two ways to write the answer for this. And one of them is where we do the squiggly line here, x such that x cannot equal negative 4. Because again, if we put in negative 4, we're going to get 0 in the denominator, and then that's an error. Can't do that. Or we can write it in this other notation where we're writing coordinates kind of. It's negative infinity, not including, of course, up to negative 4, not including, and then, of course, negative 4 up to infinity. That just indicates that there's a gap at negative 4. And there's our answer for that guy. So now we're on to 24. And we need to find the intervals for this line for increasing, decreasing, and constant. So we'll do increasing first. And we can see that our line starts, as we look from left to right, increases in value for y from negative pi over 2 to pi over 2. So just write that over here, negative pi over 2 and pi over 2. And we have no other increasing components, so let's do the decreasing. And we can see we have two sections of this line that are decreasing as we read the line from left to right. So we have negative pi to, I'll write that here over here so we don't forget. And then the other part, end of this decreasing section is the negative pi over 2, this part right here. So now we just add that to the coordinate. Now we're going to have a little gap here, so I'll just put the union sign because we have the gap between negative pi over 2 to pi over 2. But pi over 2 is where we start our next decrease, and we go to pi. So we'll put pi in here. And we're done with all the decreasing areas. Now for the constant areas, well, we don't have any constant areas. We're either increasing or decreasing, so we have none here for constant. We don't have any flat spots. So let's move on to 25, which is the same problem, except we have a different line. So let's do the increasing section first. And we see that we only, again, have one increasing spot. And that is from negative 1 to 1. So we'll write that down here. And then we'll look at the decreasing portion of this line. And the decreasing portion of the line starts at -3, goes to -2, so this spot, and then this part from 2 to 4. Now we're just looking at the x values because that's what the function would be, so underline all these x values, and then I'll write them into the interval notation over here. So we've got -3 to -2, and then we have a little gap, and so I put the union sign, and then we have 2 to 4, and those are our two decreasing sections. Now in this problem we actually do have some constants. We have this one here, and we have this one here, even though they're only one unit apart. They are still constants, so write down constant here. And we start at -2 to -1. And then we have that increasing gap. So again, we're going to put the union sign here. And then we have 1 to 2. Oops, wait a minute. What am I doing here? Hang on a second. Not -1 to 2, or not -1 to 1. I gotta erase the -1 as well. Hang on a second. There we go. All right. Let me write this correctly. We have 1 to 2 as a constant. So there you go. Move on to the next. So move on to number 26. And find the absolute maximum and minimum of the function if it exists. Well, if we look at this guy, we have the maximum is here. It goes through this line right here. Or the point touches this line here. So our maximum point on this squiggly line, I guess, is really 3, 6. So write down maximum is 3, 6. Now, this is why I was talking about that including and not including situation here. If you look here at our minimum, we see the lowest point here is 5, 1, but it's got an open circle. So that means that is not included in this whole thing. So our minimum gets infinitely close to 5, 1, but never touches 5, 1. There's a gap there. And so our minimum is really kind of undefined, or none. So that's what I'm going to put for the answer on this one. And then we'll get down to number 27. And what's the minimum maximum for this one? Well, our maximum, there isn't one because we have this vertical asymptote here, which means this goes on forever. It gets infinitely close to that line but never touches it. So maximum, well, there is none. The graph goes forever. Graph goes to infinity and beyond. All right. So our minimum is 1, 2, and notice it's filled in. This little dot in here is filled in. So our minimum is actually 1, 2. So there you go. There's my answer for number 27. Okay, number 28. Well, our minimum and maximums, we see these little open dots again. So there's a little gap between in our line technically at those points. So our min and our max are none because both of those points are undefined. So none, none, and or undefined, undefined, undefined. So All right, so now we're on to 29, and we want to graph these functions. So we'll start with this guy. F of x is equal to x plus 5. So we're just going to sub in these numbers for x. So negative 8 plus 5 is equal to negative 3. So for our x input, we used negative 8, and then we got a negative 3y value. Now let's sub in the 2, and we're going to get 2 plus 5, and that's 7. So for our x, we have a 2, and our y is a 7. Now we're going to plot these, and we have to look at the greater than equal to, less than equal to, or equal to sign, this location. Since this is less than or equal to, we do a solid dot at that coordinate. And since this one is only a less than, it's going to be an open circle at that coordinate because it doesn't include the 2. And so this function is actually this line here. So next we'll do this next one in orange. And so f of x equals negative 8. Well, that's just telling us what the y coordinate is. So at 2, an x of 2, our f of x is negative 8. So we just have one point here, and it's obviously equal to, so it's going to be a solid circle. Now we'll move on in green here. I will do this function of negative x plus 3. And it's anything x, anything bigger than 2. So negative 2 plus 3, well, that's 1. So for an input of 2, my result is 1. So that's my y. And this is a greater than sign. There's no underline, so it's no equal to. So it's a circle. Now, how do I draw this line? Well, there's a couple ways to think about it. We can just move on to the next larger x value, which is 3. We can substitute that in, and we get 3, 0 is our next number. But we also know that that was a line anyway, so the slope is technically in front of the negative was the slope, negative 1. So that was the slope. So there you go. That is number 29. For number 30, we graph these functions. And again, we're just going to substitute in our numbers here. If our x value is 0, well, we really don't have a formula. The function of x is equal to 1. Well, we got 0, and then we'll just say x equals 0, y is going to equal the 1. So we will have 0, 1 as our point for, our point for this. And same thing for if we sub in the 5. We're going to have x equals 5, y is going to equal still 1. So we are going to have 5, 1. 5, 1. Now, little hint here. This 1 is the same in both coordinate ordered pairs. This is 1. This is going to be a horizontal line at 1, just so you know. So, anyway, let's look at this guy. And our function is the absolute value of x. Well, we have the absolute value of 5 is equal to 5. So we are going to have 5, 5. The absolute value of 8 is going to equal 8. So we're going to have 8, 8. Now finally, let's do our function of x is equal to the square root of x. And it is 8 is greater than or equal to x. Oops. Sorry, 8 is less than or equal to x. So I'll do 8 first. Square root of 8, that turns into 2 square root of 2, right? well, we pull out the old calculator here. 2 square root of 2. That works out to 2.83. So 2.83. Well, it's 2.83 and a whole bunch of other numbers, but we'll just round it to this. So our ordered pair is going to be 8, 2.83. Now let's sub in 14. This one's going to be awfully ugly number. Well, I can't reduce that any further, but I can just find with the calculator what square root of 14, which I could have done before with the 8, but this is going to end up being 3.74. All right. So for 14, x being 14, we return 13.74 for our y. All right, so let's draw this. Now, remember, 0, our x value for 0 was less than or equal to x. So since it's equal to, we do a solid line, or solid dot, sorry, filled in dot. And for this one, it was only less than, so it's not equal to. So we're just going to do an open circle here and connect those guys. So our function returns this line. Let's see if I can get this to be straight. Of course not. All right, just make a line. There we go, got it. And let's get it to touch the little open circle. Get that right on our, well, you get the idea. It's supposed to be perfectly horizontal line. It's slanted slightly, ever so slightly. I'll have to live with it. All right, so this first coordinate here, 5, 5, is also less than or equal to, so it's a filled in dot at 5, 5. This is just a less than symbol, so for 8, 8, it's an open circle. So we'll count 8 here, 8 here, and we will connect those with a line. See, when I wanted this to work, it doesn't work. And when I don't want it to work, it makes my P's into diamonds or triangles. Crazy. All right, there we go. Now we have to put in our green one here. And we have 8. 8, and then we got 2.83. So that's going to be somewhere right here. It's not quite up to 3. It's a solid dot because it's less than or equal to. And the x is less than or equal to the 14. So get over to 14, and then our y coordinate is 3.74. So that's right about here. And again, it's a filled in dot. So there we go. We'll connect those guys. That time we did the first try. It's not going to give me the right handle. So, okay, anyway, there you go. There is our number 30 answer. Let's move on to number 31. Sue wants to put a rectangular garden on her property using 88 meters of fencing. There's a river that runs through her property, so she decides to increase the size of her garden by using the river as one side of the rectangle. Fencing is needed only on the other 3 sides. Let x represent the length of the sides and the rectangle along the river. Express the garden's area as a function of x. So our fence is 88 meters long, and we want to know the area of this garden. So the area is usually length times width, right? It's our area, and we'll get length times width. Well, got 2 widths and only 1 length of fence equal 88. So let's see, we can put our, let's write the formula as L plus 2 times our W's because we have two W's, but only one L. And that's going to equal our 88. But that's this fenced section here. We have a 1W and a 2W, so that's where we get our two W's. Well, now we can solve for W. We can solve for L, or we can solve for W. But let's solve for W in this case. So that means we are going to have 2 times W equals 88 minus L. And then divide both sides by 2. It's going to be 88 minus L all over 2. There you go. Or another way we could write this is 44 minus L halves, or 1/2 L, or L over 2. We'll just put L over 2 here. All right, so we'll substitute our area formula. We'll substitute W with 44 minus L over 2. So we'll have my other marker here. I'm going to substitute this guy into our formula. Use green again. We got area equals L times W, so we'll substitute that 44 minus L over 2. Now we can distribute this L to make this 44L. Come on, pen. There we go. A equals 44L minus, and L, oops, 4L. This is L times L over 2, so this is going to be L squared over 2. Or we could write this as half, 1/2 L squared, so 44L minus 1/2 L squared. I'm going to use a capital L because if I use lowercase l, it would just be a 1, so it's not a good idea to use the L's here as a capital, as a letter. But there's our answer for that guy. Number 32 is a farmer has 200 yards of fence to enclose a rectangular garden. Express the area A of the rectangle as a function of the width x and the rectangle, the domain of A. So area is still length times the width. Here's our box, 200 yards of fencing. So really our perimeter here has to equal 200 yards or less. So we can make this any size we want as long as we don't go over 200 yards of fencing. So that's our maximum. And so we have 2 L's and 2 W's. So we can put 200 is equal to 2L plus 2W. 2 times L plus 2 times W. And again, I don't like this large L, so I'm just going to say let L equal X and let W equal Y. not so concerned with the W, but the L's are irritating me. So I'll just change these around. So here we go. There, that looks better to me. That L just looked weird. All right, so our let's divide both sides by 2 and get rid of these 2's here. There we go. Now we have 100 equals x plus y. And then let's set this up to solve for y. So we have 100 minus x equals y. So our maximum and our minimum is 0, like I said, but not included. Um, and our maximum can be 100. Write that down here. So if that's the case, we've got x, but not included. So we can write this as 0 is less than our x, which is less than our y, but it's less than or equal to our 100, not our y, because we can go all the way up to that number. So I think it should be included there. All right, so now go to number 33. And 33 says reflect this coordinate on the x-axis. Well, to reflect this on the x-axis, here's our x-axis. We're just going to change the y value sign to reflect this. So we're going to have 2, -4. So we go for 2, down 4. There we go. And that is 2, -4. Oops. Let's get this on the grid correctly here. There we go. Now you can see that's on 2, -4. All right, and this one we want to reflect on the reflect across the y-axis. So we're going to change the sign of x this time. So we have 2, 4, so we're going to go with -2. Get this on the grid correctly. We're going to have -2, 4. So that's going to be right over here. We had the big brain teaser questions before, and now we're getting these little softball lobs to us. These 2 questions pretty easy. Oh boy, transformation of functions. These last 2 are usually kind of rough, but let's see if I can muddle through this. We're going to transform this function by shifting down 6 units and reflecting across the y-axis and shifting left 4 units. And I pulled all this information out of a paragraph that was basically written here, but just for the sake of making our life easier, I wrote it all down here for us. And this shifting down shenanigans down 6 units is really affecting our y coordinate. And this reflecting across the y-axis is affecting our x-coordinate. And the shifting left 4 units is, again, something that affects our x-coordinate. If we're going left and right, we're only changing our x-coordinate, not to do anything to do with our y. So I think of this as, in terms of this example, when we have our point slope form of y equals mx plus b. The m actually, or slope, it kind of changes both the x and the y at the same time. That affects both x and y. And our b here, it only affects the x, the y. So affects y only. Okay. Now, what would affect x only? Well, if we kind of change this a little bit and say y equals m times the quantity x plus some number d um, plus b. Now we see that this d portion only affects x, so affects x only. X only. There we go. Try to get my spelling correct. So we see up here we have something that affects our y only, and two things that affect our x only. Nothing to do with the slope or the m. So I can rewrite this as y equals the square root. Now I want to affect for kind of rewrite this. Kind of a dramatic radical there, as our teacher would say, being dramatic. So I'll put our x and our original function here in orange. Now I'll do the y part first, this blue here. We want to shift it down 6 units. So I want to put it in that b section, so it's outside of the what's going on with the x. So it's not under the radical. So that's why I'm putting that here. And I can see here, oops, get my green color. This is affecting the x. So to do that, I just change its sign. So I'll put a negative out here, and this is shifting left 4 units. So I'll put plus 4 and make that the quantity of. So I end up with, see, look at that triangle for a y. Okay, y equals the square root of name times quantity x plus 4 minus 6. Now, really, I mean, I can distribute that negative to that quantity section there. And then we end up with that shifting left unit, making that subtract instead of positive as I did before. So you can just make this, distribute that negative, put that under the radical, and then put our negative 6 there. So there you go. There's that one. Number 36 is going to be kind of the same idea. I don't know if this line slope example helped much, but let's see if it helps in this number 36. We're going to shift down our 8 units. We're going to reflect across the y-axis again, and we're going to shift right 6 units. So I'll just write what our original function here is, or was, and I'll leave some spacing to add in our changes. Our, well, how much space I'm going to need here? I'll just do it right there. I'm sure that's plenty. So let's shift it down 8 units. That's affecting our y, so we'll do that outside our brackets, outside our vertical lines. So we're going down with a minus, so -8. And we're reflecting across the y-axis, so we need to put a negative in front of the x. Change the x to a negative, and we're shifting right 6 units, so we'll add 6. So that's kind of how I approach this type of problem. +6, and that's the absolute value, -8. And there you go. That's the last problem in all of these. Oh my gosh, almost 2 hours to do 36 problems, but I was doing some step-by-step stuff. Good luck with your test if you're in my class. These are all the practice questions from our study guide, and good luck to you out there. And if you're watching this video and you're not in my class or some future class, hopefully this is helpful and beneficial to you. So anyway, as I said at the beginning of the video, I'll probably just be posting my example, or my exam rather, study guide for the next video as well, as opposed to doing every chapter section uh, formulas. That was probably be a little too aggressive with me also taking 18 credits and working full time. So don't know if I'll be able to really truly commit to that. So anyway, if this was helpful, you liked it, please subscribe and all that kind of YouTubey stuff. So thanks again. Talk to you later.